Did you know 22 metallic elements, collectively called as minerals, are approximately 4% in our body's mass? That is approx 2 kg for a 50 kg woman. Minerals are present as major and trace minerals in the body, and the constituents of enzymes, hormones, and vitamins combines with other chemicals such as calcium phosphate in the bone, iron in the hemoglobin, that is heme in the hemoglobin, or else they also exist as single form, that is free calcium in the body fluids. Trace minerals required in the body are about 100 mg per day or below. Major minerals required in 100 mg per day or above. Excess of these minerals are of no use and can be actually physiologically toxic. The sources of these are the water of river, lake, oceans, roots of the plants, and the animals that consume these plants and the water containing minerals. What are its roles? So, minerals provide structure to form bones and teeth. They help maintain normal heart rhythm, muscle contractility, neural conductivity, acid base balance, helps regulate cellular metabolism. They also participate in catabolism, that is breakdown of glucose, fatty acid, amino acids into carbon dioxide and water and energy, forming calcium, cobalt, copper, iron, magnesium, manganese, potassium, sulfur, zinc, and participates in anabolism, that is build up at the cellular level, glucose forming glycogen, fatty acid into fats, converting amino acid to protein, and thereby producing calcium, chloride, magnesium, manganese, and potassium. The calcium is the most abundant mineral in our body. It combines with phosphorus to form teeth and bones. The role being in muscle action, blood clotting, nerve impulse transmission, activation of several enzymes, synthesizing calciferol, that is active form of vitamin D, helps in fluid transport across the cell membranes. Storage is in the bone matrix after it is absorbed from the small intestine. Inadequate calcium intake or ineffective absorption by the intestinal mucosa causes calcium resorption, wherein there is calcium that travels opposite from the bone into the body fluids. Thereby, body draws on its calcium reserves in the bone and replaces the deficit, and this prolonged negative imbalance later on causes osteoporosis that impacts all age group. Dietary calcium to be consumed every day is in adolescents, that is 9 to 18-year-old, is 1300 mg daily, and in adults approx 19 to 50 year of age 1000 mg daily. And it is seen that exercise helps in forming a potent stimulus to maintain and increase the bone mass. Exercise helps greater bone mass quality, helps slowing rate of the skeletal aging. New osteoblasts are formed while we exercise. Then comes sodium, potassium, chlorine, which are also known as electrolytes. These dissolves in the body as electrically charged ion particles. Sodium and chlorine being the chief in blood plasma and extracellular fluid, whereas potassium is chief in intracellular mineral. And these electrolytes modulate fluid movement, allows well-regulated constant exchange of nutrients and the waste products between cell and its internal external environment. Normally, our body has about 3 to 5 grams of iron, of which approximately 80% functionally is combined with hemoglobin in the RBCs. Iron protein compound increases the oxygen carrying capacity of blood and structurally serves as myoglobin, similar to hemoglobin storing oxygen for the release within the muscle cell. Now, India is found to be an iron deficient country, especially our women's, the pregnant women, childbearing, menstruating teenagers, younger children faces iron deficiency anemia and iron insufficiency, causing fatigue, sluggishness, loss of appetite, reduced energy and capacity to exercise, hair thinning and hair fall, and then hair loss. So either inadequate iron intake or iron absorption or combination of these affects the people. Blood, that is iron loss during menstrual cycle, ranges between about 5 and 45 mg. So next we have water. Now water basically is in the form of intracellular and extracellular fluid. Extracellular fluid includes our blood plasma, lymph, saliva, eye fluids secreted via glands, fluids secreted via digestive tract, neural and spinal cord fluid excreted from the skin and kidney fluid. All these are known as interstitial fluids. Age, gender, and our body composition affects and influences the water content in our body, ranging from 40 to 70% of total body mass is our water. You need to know 6 important functions of body water. So, the water acts as a transport and reactive medium. It diffuses the gases across the most of the body surfaces, helps in waste product elimination through sweat, urine, and feces. Water absorbs considerable amount of heat with only minimal changes in the temperature from heat, thereby has a stabilizing quality. Fluids lubricate the joints, keeping them from grinding against each other during movement. And water provides the structure and form through which it imparts to the body tissues. Water intake and output is necessary to understand. So, intake and output has to be in a balance. There are three sources of water intake: are food containing 1000 ml, liquids containing 1200 ml, metabolic processes includes about 350 ml. Now output is via urine 1250 ml, feces 100 ml, skin 850 ml, lungs 350 ml. This intake and output ratio has to be balanced, otherwise what happens is in a hot weather the water output increases drastically, or in a intense exercise environment, a humid environment, the output intake balance is lost, and thereby there will be some consequences. So a sedentary adult requires about 2.5 liter of water daily, 25% coming from the metabolism. An active person in a warm environment requires about 5 to 10 liter daily. So the kidneys reabsorbs approx 99% of 140 to 160 liter of filtrate formed, allowing 1000 to 1500 ml of urine for excretion daily. Consumption of high protein diet again accelerates the dehydration during exercise, leading into profuse sweating that causes approx 1 liter of sweat releases 600 kilocalorie of heat. 2 to 3% of body mass reduces the plasma volume that strains our circulatory system and impairs the exercise capacity, thereby diminishes the thermoregulatory control. We know that regular fluid consumption is necessary to avoid dehydration and consequential life-threatening situations. So fluid loss is equal to an overall reduction of 6 to 8% of the body mass. Now fluid replacements help maintain the plasma volume to optimize the circulatory and sweating responses. So pre-workout we need to hyperhydrate. That will help in increasing the sweat during exercise. It blunt the increased body temperature, help delay dehydration. So approx 400 to 600 ml of cold water before exercise, about 10 to 20 minutes is recommended. There are certain impacts from dehydration such as heat cramps, heat syncope, heat exhaustion, heat stroke. Now based on environmental stress and energy demands, there is something known as gastric emptying. So our small intestine absorbs the fluid after it is ingested, and then from the stomach. 7 factors that influences our gastric emptying are fluid temperature, fluid volume, fluid osmolarity, caloric content, exercise intensity, hydration level, and the pH of the body. An adequacy of rehydration is essential, especially in hyperthermia people. It's essential to prevent dehydration via replacement schedules in the recovery. Hyponatremia is something known as water intoxication. How it happens is via extreme sodium loss during or through prolonged sweat coupled with dilution of existing extracellular sodium and reduced osmolarity from consuming fluids with low or no sodium in the fluid. There is osmotic imbalance, thereby due to sustained low plasma sodium across the blood-brain barrier forces the rapid water influx into the brain, thereby causing swelling in the brain tissue that leads to cascade of events. It could be mild to severe symptoms. Mild symptoms such as headache, confusion, nausea, malaise, and cramps can be seen. Severe symptoms such as seizures, coma, pulmonary edema, cardiac arrest, death can occur. So due to prolonged intense workout in hot weather, poorly conditioned person, or if physical activity is performed in a sodium depleted state in case of low sodium diet, or there is frequent intake of sodium free fluids during prolonged exercises, or the person is on diuretic medicines, these people can suffer from hyponatremia.